Okay, dear my colleagues, welcome to fourth International Symposium on Multidisciplinary Studies and Innovative Technologies. My name is Emir Köksal. I have been working for the Department of Mathematics of 19 Mayıs University, located in the Samsun as a professor, doctor.
Memnun oldum hocam.
Pardon me?
Memnun oldum. Nice
Yeah.
to meet you.
Nice to meet you.
Nice to meet you, sir.
We have 6 presentations in this session. The duration of each presentation is 15 minutes.
Yes.
Now, the title of the first presentation is Machine Learning and Statistical Analysis Applied on Mechanical Engineering CAD course, a case study during ERTI phase in the contents of higher education. And the name of the first speaker is
Yes, it's
Kanetaki, right?
Hi, good afternoon. May
Good
I share my screen?
Well, yes, you can share your screen.
Hold on a second, please. Oops.
Okay, you can start your presentation. The duration of presentation is 15 minutes.
Okay, are you viewing my screen? Do you see my screen?
Yes,
Here?
yes.
Because
See
I
your
cannot.
screen.
Yeah, here I am. Okay, so this is Zoe Kanetaki speaking. My coworker, Mr. Georgios Bekas, will arrive in a moment. Let me post this up. On March 2020, extreme circumstances, COVID-19 pandemic, forced most academic establishments around the world to cancel all face-to-face teaching. And since the academic procedures needed to go on, the e-learning method has emerged as the immediate act to resolve the issue. The general lockdown has grounded students inside their own homes. Technical issues appear like lack of equipment and poor internet connection, or even lack of technical features. This study that I will present you has been conducted in Athens, Greece at the University of West Attica, Faculty of Engineering, Department of Mechanical Engineering, and the model selected is a second semester laboratory course. The name is Mechanical Design, Computer Aided Design 2, and is the second of the 2 series CAD course that prerequisites the knowledge of basic rules of mechanical drawings in 2Ds. Thus, on March 2020, and after 2 weeks of notice, the face-to-face environment had to be switched on an online environment with no pre-planned resources or infrastructure from both sides. This study represents the first of a 3-phase study concerning the emergency remote teaching phase, the blended phase, and the return to the normality. By analyzing a survey filled in by 2 groups of students, those outcomes aid to determine the variables that can affect student satisfaction during an emergency remote teaching environments and place them under constructs and evaluate their importance. The main goal of this analysis is to determine hidden parameters that affect student performance during their enrollment on this emergency remote teaching course. And also, most important constructs are revealed and how students perceive them by identifying their transition difficulties. In order to distinguish online learning from learning method that applies under extreme circumstances, a term has been proposed by researchers, emergency remote teaching or instructing, and it's specifically for use in unplanned remote teaching situation. Adding the word environment connects the learning procedure with the space. The term emergency remote teaching environment describes this new situation, which the teaching team provided an education framework through the COVID-19 crisis, and researchers consider that social media play a very important role in the performance of learners. This emergency remote teaching framework has 3 steps: inquiry, knowing the available resources, classifying them into the constants and variable, and designing a teaching plan. Recent studies of e-learning evaluation determine those constructs factors. The 9 constructs selected are identified by researchers according to which information quality, system quality, diversity, and assessment, a learner perceived interaction with others have a positive impact on e-learner's satisfaction. Although the synchronous method seems to be the closest to the face-to-face, the asynchronous learning seems to gain field when it comes to overpassing social issues, especially during the general lockdown period. For the emergency remote teaching of the course, a blended type of synchronous and asynchronous teaching mode has been selected in order to respond to the learning needs of different student groups. Online courses were taking place under the MST platform in groups of 20 students, and which remained in the initial capacity as it was a face-to-face. The current study is focused on 2 groups of 40 students that were engaged to this specific method, with meetings which lasted 2.5 hours for each group. Homework has also been assessed and graded to the same platform. And the meetings could eventually turn out to be a useful tool for the students who, due to lack of resources, could not follow up during the whole 2-hour lectures. The first step of the framework could not take place before the first online meeting, so the feedback concerning available resources of those 2 groups had been orally expressed. And during the second meeting, students share their suggestions about uploading videos for each part creation, need of shorter videos, use of smartphones, and use of a more familiar platform or social media. So since the COVID-19 lockdown measures limited their social life, students engaged with emergency teaching more effectively, and their motivation has been greater. According to empirical data that were evolved in observing the student behavior, we can categorize them in 2 groups: those who attend the live streaming of the course and those who watch the online upload material and work on it. The selected emergency remote teaching framework consists on a blended mode of synchronous and asynchronous method. A YouTube channel has been created, with each video corresponding to a short length which varies from 1.5 to maximum 8.5 minutes, with part modeling procedure and audio and screen recordings. By following the statistic of viewers of the social media channel and the course online streaming, the views number were higher during the period that the first online lecture uploaded. During the month of May, we noticed the curve getting flattened for a period of time and then considerably growing up in the beginning of May. Since during a theoretical online course, the channel has been promoted through the course chat's interface as a conversation thread. As soon as YouTube channel has been released online, a decrease of views in the streaming platform was noticed because the learners have found their own ways to work on their assignment by watching videos via smartphone and at the same time working on a PC program. A questionnaire has been performed. It was a web form questionnaire filled in by 31 of the 40 students that follow the framework. And constructs that were selected were consistent with previous studies of e-learning evaluation that were assigned under normal circumstances and not extreme circumstances. These 9 constructs are demographic factors, valuation factors, emotional state, technical difficulties, working on assignments, presentation modes of lecture, content, and social media. Students transition from face-to-face to emergency remote teaching environment, instructor self-efficacy, and computer self-efficacy. In the light of the experience gained from this learning phase, the students of the two groups uploaded the responses and the collected data underwent a rigorous statistical analysis that will be presented in the following second slide. So a correlation analysis is performed to point out the most important correlation among all the nominal variables. Statistical importance is identified by distinguishing the variables whose lambda coefficient is above 0.3, which is indicative of a strong correlation between the two variables. It can be noticed that there is a rigorous correlation between how the student assess the level of the module's innovativeness and the perceived quality of videos. The symmetric coefficient displays also that the result can be considered statistically significant as the proximate significance is below 5%. A cluster analysis takes place through the use of the k-means algorithm, segregating the sample into two groups of students. The number of clusters is determined according to the number of clusters that is generated by a dendrogram at the highest level of its branches after an hierarchical clustering analysis. The most significant differences between those two clusters have been indicated in the present study. The final cluster feels more insecure and exhausted and thinks that the provided videos are of a lower quality and less clear in comparison with the second cluster. And as regards the time needed in order to become familiarized with the platform, cluster 1 seems still struggling after online attendance, whereas cluster 2 became familiarized with a time period that took between 15 and 30 days. The most important criteria with significance below 0.05 for the aforementioned clustering along the ANOVA, along with an ANOVA analysis, are shown in the table. And this conclusion is reached because the ANOVA analysis compares the difference between the individual clusters and within the individual clusters. For each one of the 9 constructs, a factor analysis is performed by using the algorithm of the principal components analysis, PCA and VA VROOM3 type of rotation. The number of components is automatically chosen by SPSS according to the point where the scree plot reaches a steady rate. The highlighted loadings within the tables denote the highest impact that a particular variable has on the generated components. Therefore, it is assumed that the highlighted highest loadings are indicative of the fact that a particular variable primarily influences the component on which the highest loading appears. In this slide, we will analyze the factor analysis applied on the construct regarding the commitment of students to the assignment, where in the first component, an implicit relation is revealed between the time students need in order to fill their assignments, the time that they prefer working during the week or at the last time before the lecture, as well as during the time of the day students work on their assignments. And in the second components, there is an implicit relation between the evaluation of the assignment's load and the time that the students prefer working on their assignments. In this slide, we will present the factor analysis applied on the construct regarding the transition of students to the emergency remote teaching synchronous lecture experience. And in the first component, an implicit relation is revealed between the student's preference to the e-course or the face-to-face or either to the asynchronous method, and if they would recommend the online course. In the second component, there is an implicit relation between how interesting they found the e-course, how soon they have got to familiarize with the platform, and if the attendance of this e-course helped them attend other courses. Another analysis that was performed on a group of questions that follows a sequential Likert scale logic concerns the calculation of the Cronbach's alpha coefficient to investigate the internal reliability of the answers. And if the questions of how enjoyable the module is in comparison with other theories would be removed, the aforementioned questions would attain an acceptable level of internal consistency, More detailed and like-for-like questions should be added in order to increase the consistency. A univariate analysis has been performed on individual variables. 20% of students miss the social contact with other students, even though 63% do not feel insecure about the emergency online learning. 33% feel insecure when it comes to pass the end of semester test. And the reason for this can be found either on the non-consistency of the difficulty level of the final test. Usually, final test is much more difficult than the assignments fulfilled during the semester, or at the student age, they are on the second semester of their studies and they are still not comfortable on passing final exams. Concerning the outcomes of this research, the present study is the first step on evaluating the student satisfaction during this emergency remote teaching framework on the specific module, the CAD course. And since the emergency remote teaching environment will be applied on the winter semester of 2020-2021, findings of this study have determined factors that need to be analyzed with more detail. One of the most important conclusions is that students seem to appreciate this framework, even it has been organized in such a small period of time. The cluster analysis reveals that primarily there are two main groups of students, one of that seems to lag behind and one more high achieving one. A strong correlation between the evaluation of the module innovativeness and the degree of quality of videos has been discovered. And from the instruction side, this emergency remote teaching framework is considered successful since there has been an 80% success rate on the final exams, out of which 60% of students' grades were between 8 and 10 points out of 10. At this point, the epidemic expansion worldwide does not allow educational institutions to precise the length of an emergency remote teaching, their transition to the blended phase, or even back to normality. Also, the fact that during the winter semester of the CAD 2D course will be followed by freshmen, all previous experience in this field is proven extremely useful. Thank you very much for watching, listening, and sorry about the time.
Thank you very much for your presentation.
You're welcome, sir.
Is there any question, remark, or comments? No question. Thanks again for your presentation.
Thank you very much, sir.
Okay, dear participant, normally Mrs. Nema is the second speaker, but because of the Professor Yun, who owns the paper numbered 9, connects from Fir East, then he wanted to replace the order of the presentation. So if you don't mind, I want to invite Mr. Yon, the owner of the presentation numbered 9.
Okay, so Hojam, I'm gonna be
Okay.
the third one.
Nema?
Hojam, I'm gonna be the third one now.
Yes.
Tamam, olur.
Yes. The person who owns the article number 9 wanted to present his papers secondly, then
Tamam Hojam.
if it's okay for you, then I want to invite this person.
Okay, no problem. Okay.
Actually, we from Malaysia, because now it's a very late night already, so we would like to present first. Okay, so sorry about this. Maybe I will let my student, Mr. Choi Chen Wing, will present our presentations. Okay, Mr. Choi, please.
Yes, okay. First of all, I would like to thank you for giving us this opportunity to present first. So we are from this Thai UC University. So me, Choi, and Professor Lee and Professor Yu over here will be presenting for this quantitative slam. Can you guys see my screen?
Yes, it's obvious.
All right, thank you. All right, okay, first of all, our title will be the cognitive simultaneous localization and the mappings, which is called the C-SLAM. Okay, first of all, the introduction to the SLAM. SLAM actually is a simultaneous localization and mapping, actually is a well-known algorithm in the autonomous mobile robot research. So it allows the mobile robot to localize itself in the unknown environment, and at the same time, it builds a map according to the layout of the environment. So as you can see from the picture over here, the red line over here is the path that the robots will be go through, and this is the map that have been plotted out by the robots. So this is the basic, the fundamental of the SLAM. So next will be the problems. So because the current SLAM algorithms is only contained for the geometry information, it does not contain any much more information other than the geometry information, which is those kind of 2D version. But instead of it, we want to have a more 3D pictures and understanding of the environment. So we have to. So for now, the standard SLAM algorithm for now does not have this cognitive understanding of the whole environment. So for the example of the application is the current autonomous vacuum robots. So maybe some of you guys know that the current autonomous vacuum robots is only do the job of cleaning of the living room or those kitchens by doing the zigzag without having the cognitive understanding of the whole environment. So let's say there's this implementation of this cognitive understanding, then this robot will know this environment. Let's say, for example, living room might not have so much of dirtier or maybe not much of dust, so it might do less work and it will be much more effective. So if let's say if there's a kitchen, so it will do more cleaning process for it based on their understanding of the cognitively of the environment. So this is the basic, the reason of implementing of this algorithm. So our research objective is to study the object recognitions algorithm for the cognitive system of the autonomous mobile robots. Secondly is to design a cognitive SLAM solutions that are able to simultaneously localizing and mapping through the cognitive systems. Lastly will be to analyze the factors that affect the performance of the autonomous mobile robots through cognitive understanding the environment. So this will be our research scope. We will study about the object recognition algorithms for the cognitive system of the robots and the implementation of the cognitive SLAM, C-SLAM, to understand the unknown environments connectively. So this is some of the literature review that have been done. So there will be the commerce. First will be the commerce UMass. We have done the UKF SLAM. This is all the previously the prior paper that have been done, which is the UKF SLAM, EKF SLAM, and also the Visual SLAM. Actually, these three SLAM will be much more, can say much more similar to our algorithm. So let's take a look at the next page. So Visual SLAM will be using the basically will be taking the pictures and the videos, and ours is the cognitive SLAM. So this is the comparison for the SLAM solution between the Visual SLAM pictures because it's quite similar to ours. So first of all, the Visual SLAM only have the image visual and the obstacle detections and also the 3D visualizations. But for the cognitive SLAM, it have the cognitive ability and also the environmental recognitions, and also included those kind of feature that Visual SLAM have. And with the map plotting also, this is the advantages of it. So next will be the advantage of the UKF SLAM, EKF SLAM, Visual SLAM, and the cognitive SLAM. So for now, for the basic SLAM, which is the UKF SLAM and the EKF SLAM, so they have a much accurate and reliable estimation, but it does not apply to the real life practical applications. And for the EKF SLAM, they have a much more complex computational calculations. But for our cognitive SLAM, it might have the disadvantage of it. It might need a lot of big storage to store all those informations that have been captured of the data. But it able to present out all those data in a much more understanding ways and able to recognize the unknown environments. So for now, the summary of it is actually this cognitive SLAM, previously there's no other research works that have been done before for these cognitive algorithms. So the benchmark of these results actually will be comparing within the experiment setup that have been planned out to determine the accuracy of it. So next we're going for the methodologies. First of all, the methodologies will be, we are going to utilize algorithms called the VROOM3, which is the object recognition algorithms. We will take the data set from it and we will go through the NN networks and it will go to a train. Then after that, it will go to the cognitive algorithm. And by that time, at the same time, the Pi camera will capture the image of it, of the unknown environments, and it will send through the Raspberry Pis, and it will combine the image and the data that have been trained. Then it will calculate out and predicts the unknown environments. And after that, it will go back to the main system, the main control system, which is the ROS. This ROS will be controlling our Turtlebot over here. So it will be doing, at the same time, it will do the mappings, and also at the same time, it will do the navigations. This is the main methodology of it. Next is the experiment setup. The first setup will be the Turtlebot will place at the center of the partitions, and the image will be captured at random directions. Setup 2 will be the Turtlebot will be placed at the center of the partitions and capture image for 2 corners of the partitions. Setup 3, the Turtlebot will place at the center of the partitions and capture images for 3 corners of the partitions. Setup 4, lastly, will be the Turtlebot will be reached at the entrance of each the partitions, and the image will be captured from the entrance. This will be the setup that have been done and planned in order to conduct for the experiment accuracies. So next will be the environmental venue. So this one we have to conduct all those experiments set up inside the house, all those venue. The house A, this one will be at the apartment. The house B will be the double storage house. Okay, so we will be doing the setup will be at the entrance, which is a setup 4 will be at here. If let's say for the center, we will put it here. The robots will be here and it will capture all the image according to the setup that we have been planned. This is we have been planning for 5 houses that have been used as an experimental venue. Next will be the cognitive algorithms. So this part will be a segment of our cognitive algorithms. So here we will come out the data that have been trained from the YOLO object recognition algorithms. Then after that, we will use this part segment of the algorithm over here to come out with the predictions and to compute out the results of the unknown environments. So this is the sample of the ANN data inputs. So the output of the ANN will be come out with, there will be a toilet, study room, bedroom, kitchen, and lastly will be the living rooms. So everything that have been captured by the YOLO algorithms, the data output will be from here. So this one will be take it as our input, and based on here, we will train the model and it will compute out the results that we want. So this is the basics of it. So this is one of the example of the videos that been captured during the experiments. So the robots will be moved to the center of the partitions, which is at the living room there. Okay, here is the ROS system. So it currently is moving, as you can see from here. The robot is starting to move, and it will also plot out the maps. And after that, after it stops, it will take the pictures by using the Pi camera. Then after that, this data, this picture will send back to the cognitive algorithm, and it will calculate and start to predict. Then it will come out with the results where it detects that objects that have been recognized, there will be a couch, which is at the river room. So that's why after the based on the train model, they predicted that this is the living room with the confidence level of 99.38%. Sorry, this is a bit blur. Then after that, the robots will know that this, sorry. Okay, yes, after that, in the robot, the control system there, so it will store the information, the environments back to the robot's control system. So the robots will know this is the living room. So at the end, so it will come out with the results, with the maps that show that, okay, this environment is the living rooms. Okay, this is end of the videos. So we were going to proceed with the next one. So this one will be the YOLO V3 algorithm that I mentioned for the object recognitions. This is the result of it. So there will be this section will be at the living room. At here will be the kitchens. Next will be at the bedroom. So as you can see, this is the sample of the cognitive algorithm results. I think as you can see from my videos there, so there will be show outs what have been detected. So it will base on the kitchen's utilities there. Okay, the robots were able to predict that this, and also able to understand this environment, it is a kitchens. So at here, so they will know that in the robot system, it is a kitchens. So this is the maps that have been plotted with the environments, names, and confidence levels. So this will be the results and the analysis. House A, accuracy of it. Then there will be 5 houses of it. Lastly, I think we will go for the overall accuracies. So from here, the setup 4, which is at the entrance to capture all the image, will be the most optimal results. So this might be the best, the setup, the experiments within these 4 setup that have the highest accuracy and the optimum accuracies. So next will be in our conclusion and the future works. That's that actually the objectives were able to achieve where the cognitive SLAM have been introduced to improve the current SLAM problem. But actually there is also a limitation whereby there's the unpredictable environments might affect the accuracy of the recognizing environments. So for example, the placement and the arrangement of the utilities in the environments might affect the inputs given for the cognitive SLAM. So it is still subjected to the captured data from the unknown environments. So in order to solve this in the futures, we might deduce a new solution or algorithms that allow the autonomous robots to capture the data more accurately, and it allows the robots to understand the environments in a much more accurate way. All right, thank you. That's all for my presentations.
Thank you very much for your presentation. Is there any question?
Hisham, actually, I have one.
Okay.
Thank you. First of all, thank you for this wonderful presentation. I want to ask you about the accuracy. Slide 20. he mentioned, or you mentioned, about the optimum accuracy, and
Yes.
I think it was like, yes, please, if you can open it.
Yes.
Yeah, at the
Right.
optimum setup,
Sorry. Wait. Yes. Can you see it?
you have, for example, a setup 4, you have 81, 99% is very good, but you have 53 accuracy. Is there any, like, why? We can say why you have here 53%, and you can have 99, and you can have up to 80%. Why this one? 53. Any problem?
Yes, actually, this one, as I said, the limitation is still have to subject to the placement of the utility lah. So as you can see, based on the previous result, the setup for some of it is quite high, but some of it, as you say, it's a bit lower. It's like not that excellent the results. So this kind of situation or issue is happening is because of the 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 data that have been captured is quite limited. So if let's say there's inside the kitchens, so if let's say there's how to say if let's say there's a TV or maybe other like computer everything at there, if we put at the kitchens, so the at here we have the limitation that the accuracy might not able to understand this environment is the kitchen. So this kind of unknown situation, which is the placement and the arrangement of the utility, is kind of is affect our accuracy. Yeah, this is the problem.
Thanks.
Am I able to answer your questions?
Yeah, thank you.
All right, sure.
Thanks
Any
again
questions?
for your presentation. Is there another
All right.
question? Comments or remark? No question. Okay, the next speaker is Mrs. Nema. The title of her talk is on potassium ferric unit electrochemically detected by differential pulse and square wave voltmeter in a computation using gradient boosting as machine learning algorithm.
Yes, Hujam, it's my turn now. So let me share my screen first.
Okay. Press the button, share screen.
Yes. Can you see it now? Everyone, is it clear?
Just seconds. Yes, right now. Okay.
Just okay, first of all, good evening. It's my pleasure to welcome all participants, Hujalar and guests. My name is Nima Shamma. I'm a student at the pharmacy faculty in the analytical chemistry department at Near East University. Let me just introduce to you my team members in a little bit more detail. I'm going to start with Sulaiman Hoja at the Department of Material Science and Nanotechnology Engineering, then Kamil Hoja, Department of the Electrical and Electronic Engineering, and finally Mehmet Hoja at the Department of Biomedical Engineering. So our work is talking about the potassium ferricyanide electrochemically detected by differential pulse and square wave voltmetry in a competition using boosting as a machine learning algorithm. So to begin with, I'm going to introduce the electrochemical detection first, followed by some definitions about the electrochemical techniques, types. Then I'm going to explain the differences between the two techniques, voltmetric differential pulse and the square wave voltmetry. Then I'm going to move to the second part, which is talking about machine learning, gradient boosting. Then I'm going to talk about our objective in this study, methodology, and finally, results. So, as you all know, the detection of chemicals, biocompounds has the trend nowadays, especially to detect some diseases such as COVID-19. So usually researchers are looking for the simplest, low time consuming and sensitive procedures for detection. Actually, or hence, we can say that the science is going forward the electrochemical detection because it goes or it fits to that purpose. Plus, the hyphenation with other fields such as machine learning can be a supportive to give us supportive to give us efficient and sufficient outcome. So first of all, let me define what is electrochemical detection. Generally, we can say it's the use of different analytical procedures that provide quantitative and qualitative information. For example, when we want to detect the concentration of iron metals, for example, in seawater samples. So different devices can be used related to the procedure selected. And why does it called electro? Because usually in this method, electrical current is measured as a result of some reactions such as redox reactions when a potential is applied. Also, we have different types of electrochemical detections: colorimetry, potentiometry, and voltammetry. And in our study, we are interested in voltammetry. So voltammetric techniques, it's a type of electrochemical techniques that we apply what a pulse or differential or a potential pulse to the system electrochemical cell, and we are waiting for a chemical reaction, then the current should be measured. This is like a figure introduced to you our system or our apparatus. We can see electrochemical cell, potentiostat to give us the potential. We need three main electrodes: working electrode, reference electrode, and counter electrode. Instead of the electrolyte, we can put our chemical, which is ferrocyanide. The output, what is the output of our voltammetric technique? Actually, those are three main familiar voltammograms. We can, as we can see in A, B, and C, current versus potential. Once it's increased the current, 1 point, we can have a limiting current until the diffusion layer is increasing by time. We can have like C, a peak, like a peak shape. And this, we can have our data about the reactivity and the concentration of our analyte. So usually voltammetric techniques also have different types, such as linear sweep, cyclic voltammetry, differential pulse, and square wave. In our work, we are concentrating on differential pulse and square wave voltammetry. So what is differential pulse? Generally, we can say it's like the application of potential pulse that should be fixed, range from 10 to 100 millivolt, and then the current, as I said, should be measured. Here we have 2 points. The first point before the application of the pulse and the second one at the end of the pulse. Then we need sampling points. Then the differences between the current should be measured, and we will have voltammograms, as I said in the previous slides. What about the second detection? It's square wave voltammetry. Here we have like a base stairs or staircase of potential, and we can see this in those here. We can see here in this voltammogram, this voltammogram indicates the output of square wave voltammetry, whereas this one indicates the voltammogram of differential pulse voltammetry. And in general, we can say the differences between them in sensitivity, complexity, and time, also in the differentiation between the fast and the slow kinetics. As we can see here for differential pulse, and this is the outcome for the square wave voltammetry. The second part, which is machine learning, as you all know, we got our data from the electrochemical detection and transfer it to machine learning. As you all know, the definition of machine learning, which is the application of AI, artificial intelligence, that provides the ability to automatically learn and improve from experience with a minimum human efforts. And also, machine learning has a lot of application in different fields, such as computational finance, image processing, even in biology, and chemistry, and drug discovery, plus DNA sequencing. And finally, we can find it in natural language processing, such as voice recognition. What is the model? We choose here gradient boosting model for data analysis from that we obtained from the electrochemical detection. And finally, we can summarize our objectives of this work in 4 main points. First of all, we need to compare the two sets of data with two instrumental methods, which are differential pulse and square wave. Then we need to check the robustness of those data, which is obtained by electrochemical detection. 3, we need to find the suitable machine learning model for classification, the data analysis. And then those data analysis should be obtained by the two fields should be efficient and sufficient as well. So what is our method? Of course, because we are using electrochemical detection, so we need some chemicals. So we prepare potassium ferrocyanide and potassium nitrate. And we need, of course, phosphate buffer solution with a pH 7. And we prepare different 5 concentrations from 2 till 10 millimolar per liter. And the apparatus, of course, which is NOVA 21, which is a potentiostat, which contains 3 electrodes, as I said before, working, counter, and what is it? Reference electrode, yes. And all those experiments done under room temperature, 25 Celsius. So what is the procedure? For working electrode, of course, we need a graphite pencil. We cut those graphite pencils. We clean it. By using the buffer, we use chronoamperometry. Then we detect the different 5 concentrations, 2, 4, 6, 8, and 10 millimolar of ferrocyanide using 2 techniques, the differential pulse and square wave. Then, after we obtain some voltammograms, we took those data and move it to the machine learning for application and data analysis. As we can see, those voltammograms, for example, figure number 4, for the differential pulse, we have 5 peaks because we have different 5 concentrations. We are seeing increasing in the peak, in the high peak, it's increasing because the concentration is increasing as well, so the current is increasing also. The second one, the same for square wave voltammetry. And then this is the results for machine learning. As we can see here, our data, y-x-axis, and we have the values from 0 till 4 because we have 5 different concentrations. So 0 is here is a value. As you can see, the blue one and the yellow one, which is the blue one actual data and the classified data. We give the machine learning like 60 for training and 40 for testing. Of course, they are not identical because we have like percentage error. The accuracy is not 100%. As we can see here, training, as I said before, 60% for both techniques, and the testing data was 40%. And the accuracies for the differential pulse obtained from machine learning was 75, whereas for square wave was 60%. So to conclude, both techniques, differential pulse and square wave voltammetry for our analyte, which is potassium ferrocyanide, it is studied and was no problems during its oxidation reaction. We can see the differences between the sensitivity between the two techniques through the output. Machine learning technique proved its ability to apply it in even chemistry fields and drug analysis, and we are looking forward for future work to reach or to get accuracy higher than 90% or up to 90%. That's it for now. Thank you for listening to me, and if you have any question, you can ask.
Thank you for your presentation. Is there any question, remark, or comments? So everything is obvious. Thanks again for your presentation.
Thank you. Thank you very much. Hujam, can we have this recording for this conference, or is it hard?
Yeah, I will ask the chairperson of the conference. Okay. then if you accept and approve, then I can send the video recording.
Yes, please.
Okay.
Thank you very much.
Okay. The owner of the next presentation is Mr. Zaniap and then Zaip, but the owner of the second presentation from the last, Mr. Zanat, connects from Kazakhstan. So he wants to give the presentation right now. So the owner of the next two presentations, number 100 and number 336, accept, and I want to invite the owner of the second presentation from the last.
Hello, everyone. Can you see my presentation?
Yes.
Thank you.
Yes.
My name is Janat, and I'm from Kazakhstan. I'm really nice to meet everyone here. Hope you're all good and safe. So for today, our topic is mathematical model of curriculum development, taking into account individual preferences of students. So why this topic is so important? So in the case of organizing an individually oriented approach to master the educational program, each student should make his own individual study plan. And at the same time, a student faced a number of problems like choosing university to study a particular model, choosing training courses within a model, etc. So we assume that the student is interested in receiving high quality education, possesses all the necessary information for making decisions, including information on the quality of educational service at each university, information on the teaching staff involved in the educational process. And also, we believe that the student already has the ability to go through any model in any of the universities that implement SOP. So now let's talk about some statements of the problem research. And the first one is setting student preferences. So the student preferences should reflect their desire to complete a specific model at a particular university. We suggest using fuzzy sets as a tool for this. A fuzzy set is a collection of elements of an arbitrary nature with respect to which it is impossible to say exactly whether these elements have some characteristic property that is used to define a fuzzy set, as you can see here. So the second one is description of restrictions. First and foremost, it must be followed structurally, logical connection of the material being studied. Secondly, the totality of the IEP should not contradict any capabilities of universities. Also, at the end of studying, a student is awarded a diploma only from a basic university, and the diploma supplement the lists, models, disciplines, and practices that the student has completed at other universities or organizations. And in this case, the student must pass K models in other universities. Also, as funding of universities is normative per capita, the redistribution of students among universities may lead to mismatch of funding to the real number of students in the university. And finally, I'm going to talk about the optimality criteria. It means that the students' preferences are set by fuzzy sets in which a higher value of the membership function corresponds to a greater desire of the student to study the model at a particular university. Accordingly, for maximum satisfaction of students when constructing the IUP, it is necessary to maximize the vector consisting of the values of the membership functions of the current set of IUP by the specified fuzzy set that was told before. So thus, the solutions must meet the following requirements. At the beginning, IEP, all students must be consistent with the matrix of dependencies of the models ED. Secondly, they should run the resources of the university given below. Thirdly, each student must complete the K models at other universities. In other words, a certain number of models must be passed in other universities, but their number cannot exceed half of all the models. And finally, the difference between the total number of student models the students of the nth university have completed in other universities, and the number of student models that were conducted for students from other universities in the nth universities should not exceed the specified value of R given below. Now let's talk about the prototype of the curriculum information system. The prototype information system had a three-tier architecture. In it, each level performs its tasks and has its own functionality. At the first level is a client application, which is a presentation layer of the system. The second level is responsible for the business logic of the system and interacts with the presentation layer, responding to its requests. The second level is also called the application server. At the third level is a database that is responsible for storing data and its integrity. So here you can see this pattern, and in the created IS, the three-tier architecture, as I already said, will be a web application, where the first level is the user's web browser, the second is a web server, and the third is a database. Yeah, and the web application itself will be built using this model view controller design pattern. This pattern divides the work of a web application into three separate functional rules: data model, user interface, and control logic. Thus, changes made to one of the components have the least possible effects on other components, and the block diagram of such template is shown here in this figure. So also, the IES architecture constructed in accordance with the selected, as I already told, MVC design pattern and three-tier architecture is shown in this figure. Let me explain it. So it is possible to distinguish the first level in it. You can see here, a web browser with which users work in their workplaces. Second one is a web server that contains a data model, a layer of business logic and business operations, and a presentation layer. And the third level is a controlized database. So it is at the second level that individual student curricula will be compiled. In the framework of this work, only one presentation is implemented, the web presentations. So in this slide, the figure 4, this figure, shows the set of optimal IS students formed with the help of this, taking into account their preferences. In addition to viewing the generated IEP, representatives of the university also have access to the following sections. So the first one is working with students' data, setting for university restrictions, also work with study groups of students, and of course, configure the configure the properties of the SOP. So this figure is appearance of the workplace of the university representative in the developed information system. I'm sorry, it's very late in our country now. So in conclusion, so to sum up, the actual scientific and practical problem of developing models and software for decision support in managing the network interaction of universities, the condition of implementation of network educational programs was solved. And what does it mean? Yeah, so solving this problem makes it possible to increase the effectiveness of managing the network interaction of higher education institutions in the modern system of higher education by using intelligent decision support tools in the construction and adjustment of individual curricula of students studying on a network educational program. Thank you all for attention. Nice to meet you, everyone.
Thank you very much for your presentation. Is there any question, comments, or remark? No question. Thanks again for your presentation. Okay, the next presentation is about the coronavirus, which is currently equipping the world's agenda. I hope you will get through this process without any problems and we can meet you face-to-face at other international conferences. Okay, the name of the next speaker is Mr. Zaniab, and the title of the talk is on the predicting COVID-19 trajectory using machine learning. Dr. Zaniab? Present or absent? Or Abdullahi Ibrahim? I think they are not present. Okay. The last speaker is Mr. Zaid. The title of his talk is Securing 5G Network Using Low Power Wireless Personal Area Network.
Hello, good evening, everyone.
Good evening. Hello.
Is the screen is obvious?
Yes, sure.
Okay. My name is Zaid Ali Said Al Sarrai. I am a master student at Altenbash University College. I'm going to talk about securing 5G network using low power wireless personal area network. The outlines is introduction, the aim of the study, problem, methodology, sensor node, results, and conclusion. At the first, the development of communication system in the present day brings with it new opportunities and will determine profound change in our lifestyle and the interaction between humans and systems. 5G is a new network model that combines old and new technologies and responds to the increasing demands for the data due to the increasing number of entities accessing data, communication services, and new applications that consume resources. In the vision of 5G infrastructure public-private partnership, in the future countries, there will be a huge amount of data and heterogeneous knowledge available to everyone, everywhere, in real time. The aim of the study for this paper is to secure 5G network using by low power wireless area network that secure 5G network and consume less resources, as the 5G network security is a large subject. The focus will be on the new technologies of the 5G. The framework should support understanding of how system services are tied together in securing fifth generation using low power wireless personal area network in MATLAB environment. The framework should be easily applied to the industrial level of the organization. Of course, we must talk about the problems. Security issues may arise in the potentially untruthful environment. For example, if your network and application provider suffers from security vulnerabilities, stack holes might be exposed to attack to their security to code. Wireless communication and network have become dominant force in commercial business, military operations, and everyday life of typical consumers, such as networks are an essential component of modern societal infrastructure and continually expanding to meet demand. About the methodology, the purpose reinforcement learning algorithm for securing 5G network is designed for mesh topology from the ground by the model of the network itself using low power personal area network. We model the network operating in a finite area with a finite number of nodes distributed inside the area randomly in this algorithm. Hence, we defined the service are of the target network by assuming the finiteness of the network in the model. We then model the connection between the nodes in the network. In this model, we consider that any two nodes are adjacent when they are certain range and can establish connection between each other. This figures shows sensor nodes that are considered being powered by internal battery with fixed capacity of Pmax as the solo power source. At any point, we consider that the remaining energy battery, as known as assume, all the nodes are connected to a solar-powered charger for recharging the battery. For the simplicity of the model, we emulate the charging process by resetting the P now to its maximum value, P max. This is the sensor nodes. The sensor nodes, before the sensor nodes, during this operation of the nodes, there may have several possible phases that consume the battery power, including the data collection, the data processing, sleeping, transmitting, and receiving. About the sensor node, consider being powered by an internal battery with fixed capacity of Pmax as the solo power source at any point. About the result, to evaluate the performance of the reinforcement learning for securing 5G using low power personal area network, we establish a series of simulations with different learning variables to assess the performance of reinforcement learning against the two benchmarks. We establish simulation environment that is based on that of the remote low power wireless area network model. We started by defining the characteristic of the channel used in the simulation. We determine the path load exponent, and we consider the network as far-field communication scenario. These figures show the average failure rate using the same of topologies of transmitting settings with different Boltzmann exploration hyperparameters, and these figures would show the average energy efficiencies of simulations with reinforcement learning for securing 5G using LPWAN. About the discussion, many of mobile phone applications these days for sure require you to give them some sort of personal information before even you download it. The location privacy can be leaked on the physical layer level because of the access point selection in 5G. For some of the nodes, it's going to act trustworthy nodes, and for some of the nodes, it reacts as malicious nodes. In the spiral model, there is a way to track their dynamic behavior, and though that it can be suspect at its collaborative node. The aim is to secure 5G network using LPWAN that secure 5G and consumes less resources. This paper, we proposed reinforcement learning routing algorithm for securing 5G using LPWAN that can reduce failure rate, improve energy efficiency, and carrier band usage rate of wireless mesh network for the rural environment monitoring. This kind of addressing that need network that can be provide connectivity effectively. Second, we carried a comprehensive literature review for related fields of study, including wireless mesh network, wireless sensor network, machine learning, and the wireless sensor network and other wireless mesh network. Furthermore, we modeled the remote monitoring networks with attributes of the key components, including the channel, the nodes, the links, the transistors, the transmissions, and the feedback that use the machine learning. Thank you all. If there's any question, I'll be happy to answer.
Thank you very much for your presentation. Is there any question, comments, or remark? No question. Thanks again for your presentation. Okay, we have completed this session. thank you for your participating this Session and International Conference.
Thank you too, sir.
I will ask the chairperson of the conference, then if he accepts, then I will send you the video recording. Thanks again for your participation.
Sorry, session chair.
Yes.
Yeah. Can I give you my email address when you got the approval that you can send the, the video recording to us?
Sure.
So I
You can write. Okay. I can also reach, but if you want, you can write from the here.
Okay, I write in the chat.
Chat session you can write, but I can reach and find also. You can write here if you want.
Okay, I put my email address here. Okay, thank you.
Okay.
Okay, thank you.
Okay.